Hello and welcome to day 4 of Practical English for Finance and Banking. In our last class, I introduced you to the vocabulary workbook for this course, and of course that file has been uploaded to Blackboard, so you should have done the exercises in there for Unit 27, which deals with numbers and statistics. So let's jump right in and take a look at these and see how you did. So the first section here, section A, match the numbers with the phrases. If I just say the number here, then obviously that tells us what it is here. So what I'm going to do is start on the right side here, and I'm going to go down through the letters and find which one matches over here. Okay. So 1%. 1% is like this, 1 followed by the percent sign. What does percent mean? What does that word actually mean, percent? Per means like a part of something, or for each would be a good way to say that. So per is like for each amount. What about cent? What does that mean? What is a century? Century is 100 years. Okay. In the U.S., we have a cent is 1/100th of a dollar. In other words, 100 cents equals $1. So if you see the word cent, that is related to 100. In the metric system, if you have 1 meter, that equals 100 centimeters. Cent, again, 100. So a centimeter is 1/100th of a meter. A centimeter, 1 centimeter equals 1/100th of a meter. Okay? So 1% means 1/100th. And notice the percent symbol itself. The percent symbol, there's like 2 zeros in here with a line. So that's kind of like writing a fraction where you would have the slash over 100. Okay? That's basically what it means, except they've rewritten it so as a symbol here, where the slash divides the 2 zeros, which are written very small in this case. Okay? So 1% is like that. 1,000, very simple. Oh, 1,000. What does K represent? K is for kilo. How big is a kilogram? 1,000 grams. A kilometer, 1,000 meters. Okay? So 1K is 1,000. You guys don't remember this, but when, because you would have been too young, but do you know what Y2K is? This was a huge deal. Everybody was afraid it was going to create all sorts of chaos and confusion and computer crashes and monetary problems. Y2K was year 2K, or the year the year 2000. 2K, 2000, the year 2000. Why were people worried about that? Why was that a concern? Well, when computers were invented, when they were developed, back first in like the 1950s, 60s, when they were designing these things, the year only used 2 digits. For example, 71 would be 1971. Or 99, 1999. Well, what was going to happen in the year 2000? There were only 2 places, 2 spaces for the year. So if the year was 00, then things that happened in, say, 71, and then the year changed to 00, that was going to completely mess up dates and accounting and all sorts of data in computer systems. And so they were afraid of like worldwide economic collapse or crashes, at least stock market crashes, computer crashes, air traffic control systems, used computers, everything basically, military uses, and financial markets. So they were really, really concerned that this was going to cause worldwide chaos and confusion. So they spent a lot of years, computer engineers, computer programmers, trying to fix this problem. But for years and years and years, they talked about Y2K and warned people and cautioned them that there might be power outages because the power grids, the power systems all over the world relied on computers to operate. So they were afraid that it would interrupt or disrupt all sorts of systems around the world that we depended on. Fortunately, they did prepare for this, and they put a lot of work into it. So they made it up like it was going to be this huge thing, and some people were really concerned about it. But fortunately, it turned out there weren't any serious problems. I'm sure some companies that didn't update their computers, that didn't figure things out, I'm sure there were some problems, but it was not a global crisis like they were sort of afraid of. Okay? So, next one here, a trillion. A trillion looks like this, with a 1 followed by 3, 6, 9, 12 zeros. Remember, the first comma here would be thousands, millions, billions, and trillions. So a trillion, you could also say 1 trillion. Okay? 1 trillion or a trillion. Same with 1,000. 1,000 or 1,000. Not 0.001%. What does the word not mean? Not. Well, if you look down here at the bottom, it says for American English, change not and O to 0. So, for example, 0.01. 0.01. Okay? You'll hear this used occasionally with years. In the early 1900s, people would talk about 09, 1909. 09, they would say is 09, without or not 9. Okay? Sometimes you might hear the phrase, it was all for naught. It was all for nothing. It was a lot of wasted effort or wasted energy, wasted time or money. It was all for naught. We just wasted it. Okay? So not 0.001%. What is O? Well, obviously, if you look at an O, in particular a capital O, that looks very much like a 0. So sometimes when we have the number 0, we will read it as an O. Now in the book here they're saying, oh, Americans don't do that. We do it all the time. For example, if this room is 626, let's say there was a 602. You could say 602, or you could say 602. Or my office is building 6, room 107. So you could say I just said it there, 107 or 107. If you want to be extremely clear and precise, if you want to make sure there's absolutely zero misunderstanding, you can say 107. Common usage, everyday language, people say 107. Okay? So, not 0.001%. That is this one, not 0.001% or 0.001%. Or, that is tenths, hundredths, thousandths, that is 1,000th of a percent. 1,000th of a percent. 1,000th of a percent. Okay? Not 0.01%, not 0.01, 0.01%. Not 0.1%, 0.1%. Now here you can say 0.1%, you can say 0.1%, you can also say a tenth of a percent, a tenth of a percent. Okay? So any of those are correct, are acceptable. Okay? A billion, that is this, 1 billion. That's thousands, millions, billions. 1 billion, you could also say a billion. And often written as 1 BN for billion. Okay? And sometimes, especially with money, they'll sometimes just use a capital B. Alright? So for billion, you might see BN, you might see a capital B. Okay? Alright. Oh, it looks like I accidentally clicked a couple times here. Okay, a million. Let me back up. So that was a billion. A million, often written 1M, or sometimes with a capital M. Okay, a million, that's the one at the top here, number 1. 1 million. Thousands, millions, 1 million or a million. Okay, greater than 1. The greater than symbol looks like this. That is greater than. Oh, it automatically changed my symbol there. Greater than looks like this. And of course then less than looks like this. Less than. How do you remember them? Well, the way I was taught, which I kind of like, is this less than looks kind of like a capital L that is turned on its side. Okay? So if you look at it, it's kind of like an L shape, less than. Okay? That's how I remember it. So, greater than 1, greater than 1, greater than or equal to 1. So, greater than or equal to 1. So, greater than or equal to, we combine these two symbols. So, we'll have the greater than symbol, and then instead of the 2 lines like the equal sign, we just keep 1 and put it underneath the greater than. So, greater than or equal to 1 looks like this. You read this greater than or equal to 1. Greater than or equal to 1. Less than or equal to 1 is just the opposite. Less than or equal to 1 means it's 1 or less. And less than 1 is not equal to 1. It has to be less than 1. It could be 0.9999999, but that's still less than 1. Okay? So check your answers there. Now moving on to part B, match the numbers with the phrases. And again, I'm going to start on the right side here because if I read them, then that is obviously the answer. So I'm going to start with the answer and then find the mathematical expression that matches it. So the square root of 3 is this one. Now notice here the square root symbol looks kind of like a little check mark, okay? And they've written it a little bit differently here. In the US, normally we would write it like this. The first part of it's the same, but then we have this horizontal line that covers everything that's inside. So we would read this, the square root of 3. What is the square root of 3? I don't know. It's hard to say. Because the square root means you multiply something times itself and you get 3. So what do you multiply times itself to get 3? I don't know, it's some fraction, 1 point something, I guess. I don't even know. Now, what is the square root of 9? Well, 3 times 3 is 9, so the square root of 9 is 3. Okay? 3 cubed. 3 cubed is 3 with this small 3 raised above there. Okay? 3 cubed. Why do we call it cubed? Well, cubed means you're multiplying something times itself 3 times. 3 times 3 times 3. 3 times 3 is 9. Times 3 is 27. 3 cubed. Now, if you take an image of that, then if you have a shape that is 3 by 3 by 3, or I guess we'd have to go height, 3 by 3 by 3, what shape is this? A cube. Okay, it would create a 3-dimensional cube. So that's why it's called cubed. Okay, that is the image or the geometric shape. The geometric shape that it represents. Okay, like a circle, a square, a triangle, a cube. Those are all geometric shapes. Okay? Now, 3 divided by 2. 3 divided by 2, 3 divided by 2. Or 3 over 2. If we write it like this, I probably wouldn't say 3 over 2, but if you write it like this, you have a 2, and then you have a 3 over that, 3 over 2, or 3 divided by 2. Or 3 halves. 3 halves. 3 halves. If you have 1 over 2, that is equal to 1 half. Half is the singular. Halves. Change the V. Change the F to a V. Okay? 3 halves, that's what this would be. Or 3 over 2, 3 divided by 2. D, 3 minus 2. 3 minus 2. 3 multiplied by 2. 3 multiplied by 2. 3 times 2. You can say 3 times 2 or 3 by 2. If you're going to use 3 times 2, you can write it like this. For times, for multiplication. For multiplication, or to multiply something. We can use the X symbol. 3 times 2 is 6. Or 3 multiplied by 2 is 6. Okay? For multiplication, you can use the X here, or you can do the dot sort of in the center here. It's not a decimal point. It's not down here. And leave a little space there probably. Okay, 3 times 3 times 3. This dot here is used the exact same way as this is. Okay, 3 times 2. Or 3 by 2. If you're talking about dimensions of something, or a matrix of some sort, then I would use the 3 by 2. Like this is a 3 by 2 table, or a 3 by 2 if this is a box, a 3 by 2 box, 3 meters by 2 meters. Okay, 3 by 2. If we're talking about, so if you want to say it's 3 by 2, I would use that for like dimensions of a box or a room or a piece of paper or something. Okay, if you talk about how big a piece of paper is, you'll give the dimensions in well, for paper, for millimeters or centimeters. Okay, 3 plus 2, 3 plus 2. So if you multiply, that's multiplication. If you add, then we say plus. Okay? Or here we say 3 times 2. That's multiplication. 3 plus 2, that's addition. You're adding or doing addition. Okay? 3 squared. 3 squared. A square has the same length on both sides. So 3 squared would be 3 by 3. 3 squared means 3. That would mean 3 times 3. If you want to find the area of this square, 1, 2, 3 on this side, 3 on this side, 3 times 3 gives you the area. 3 squared. And that's the shape it forms, is a square. Just like 3 times 3 times 3 gave us a cube. That's why this is 3 cubed. Okay? This is 3 squared. It just gives us a square, not a three-dimensional shape. Okay? And 3 to the power of 10. 3 to the power of 10. 3 to the 10th power. 3 raised to the 10th power. Or we can simply say 3 to the 10th. What does that mean? That means 3 times 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 3. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 3. That means 3 times itself 10 times. And I have run off my screen there, okay? But there are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Here, let me change the font size so they'll all fit on the screen. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 3 to the 10th. Just like 3 squared is 3 times 3. 3 times itself 2 times. 3 cubed is 3 times 3 times 3. 3 multiplied by itself 3 times. 3 to the 10th is 3 multiplied by itself 10 times. Okay. Now what are these little numbers called here? The 2, the 3, and the 4 here. What do we call these? The 10, the 3, the 2. Those are exponents. Exponents. Okay? Alright. Okay. That is part B. this is a sign from a coffee shop. Do you see anything wrong here? Do you see any problems? So we've got a honey ham cheese ciabatta. Okay. 1 EA, 1 each. Normally you'll see that on packaging. Normally not for a sandwich. It just means one. A complete sandwich. A whole. Okay. And then we have 2 over 1. 2 over 1 equals what? 2 over 1 is 2. So for one sandwich, it's 7,001. For 2 sandwiches, it's 3,501. That is a great price, isn't it? What have they done here? Well, for a whole sandwich, it's 7,000. For 3,500, it should be 1/2. Okay, so be careful with your fractions. 1/2. So that equals 1/2. Okay? Or half of a sandwich. Or we'd say just half a sandwich. Half a sandwich. Half of a sandwich. Alright? You do not get 2 complete sandwiches for half the price. That would be a bargain. That would be a fantastic deal. Okay? So, they have a little mathematical problem there. A problem with their fraction. Okay, let's move on to part C. Answer the questions. 3 plus 2, blank 5. 3 plus 2, which one is not possible? So 3 plus 2 equals 5. 3 plus 2 equals 5. 3 plus 2 makes 5. 3 plus 2 is 5. 3 plus 2 comes to 5. Or 3 plus 2 does 5. Which one does not work? Which one is not possible? That would be does. Okay? Equals 5. 3 plus 2 makes 5. That makes sense. 3 plus 2 is 5 instead of equals. We can say is. Or comes to means the result is. Okay. Now when you're doing addition, when you're adding, the result is called the sum. The sum. So the sum of 3 and 2. The sum of 3 and 2 is 5. If you add 3 and 2, you get 5. 3 plus 2 is 5. Okay? Which one is not, emphasis on the not here, a very usual way to say this? Which is not a usual way, a normal way. Okay? 790. If we're talking about money and dollars here, 790 means $7.90. That's exactly what it means. Okay? So $7.90, $7.90, those are both acceptable. What about $7.90? Maybe. $7.9? No, that is not correct. $7.90, I've never heard anybody say that in the U.S. Maybe that's how British people would read it, but I would not use this one. Now, where you will see that, or I'm sorry, where you will see part D here, $7.9. If it's just dollars, we won't say that. But if you have something like this, where's my dollar sign? 7.9 billion dollars. This you can say 7.9 billion singular dollars with an S. $7.9 billion. So you have to kind of go back and forth here. $7.9 billion. Okay? That would make sense, but we only do that if we have We wouldn't do it for 1,000. We wouldn't have $7.9 thousand, but $7.9 million, billion dollars, trillion dollars, that would be okay. Okay? If we're using one of those, million, billion, trillion, quadrillion, then it would make sense. Number 3, choose the best words to fill the spaces. In PC Planet, name of a store, the Micron X9000 desktop computer. Retails at $999.95. Is for sale at sounds awkward. Is bought at sounds very awkward. Retails at $999.95. $999.95. Okay. Again, when we've got a price like this, we usually just say $999.95. Why do they use big numbers like this? Why do they use large numbers like that? But not, why don't they just say $1,000? Because they want to advertise that it costs less. They want to say that it costs less than $1,000. It's less than $1,000. 5 cents. Not much less, but you'll see the same thing in Korea. That's why they sell things for 991. It's less than 1,000. It's basically the same, but mentally people think, oh, it's less than 1,000 won. It's a good price. It's cheap. Okay? Number 4, I'll work it out and give you the figures tomorrow morning. The figures, the numbers. Now, but we don't say numbers. We don't say I'll give you the numbers tomorrow morning. Not normally. This would be much more common. I'll give you the figures tomorrow morning. The results of my calculations. Okay? Number 5, I don't care how you worked it out. I don't care about your calculations. I don't care about the details. Just tell me the bottom line. The bottom line is the final result of a calculation. If you're working on a balance sheet or something like that, you have all the calculations, you have all the numbers. At the very bottom of the page, you have the final result. After you've multiplied and divided and added and subtracted, you have the end result. That's the bottom line. This person doesn't want to know, I don't care how you worked it out. I don't need all of the details. I don't need all of the calculations you did. What's the final result? What's the total cost? What's the financial damage? What's the bottom line? Okay? The bottom line here is used for money, and it's also used in other situations too. What's the bottom line? Just tell me what's going to happen. What's the end result going to be? Number 6, what's the best way to say this email address? We would read it as Anna.Brown. We don't say point or decimal or period. If we're writing a sentence, at the end we put that dot. That's a period. In numbers, $7.9 billion, if we're talking about money. But in email addresses, websites, we say dot. Anna.Brown. This little thing here looks like the letter A with the letter A with a little circle around it. That's at globalindustries.com. Anna.Brown at globalindustries.com. Okay, number 7. Alan earns 10,000. What's this L here for? That sort of cursive capital L. That is for British pounds. That represents British pounds. Why do we use an L to represent pounds? I have no idea, but we do. Okay, that's the symbol. Alan earns 10,000 pounds a year. Bella earns 20,000 pounds a year. And Kathy earns 60,000 pounds a year. What's their mean annual income. What's the mean? The mean is the mathematical average. The mathematical average. So the mean equals the mathematical average. The mathematical average. How do you find the average of something? You add everything up and then divide it by how many pieces there were. So the mean, the mathematical average, we take 20,000 plus 30,000 plus 60,000. 20 plus 30 is 20 plus 30 is, oh, I'm sorry, I'm looking at the answers instead of the things here. 10,000 plus 20 is 30, plus 60 is 90. 90 divided by 1, 2, 3 was how many pieces we had. 90 divided by 3 is 30,000. 90 divided by 3 is 30,000. That's their mean, their average annual income. Okay? Reference code, this. What's the best way to say this? I would read it as 14 slash that slanted line, like we use in fractions sometimes. That is called, we read that as a slash. 14 slash 689G. I wouldn't try to read that as 689. The way this is, because we're mixing numbers and letters, I would read it as 689G. This, excuse me. The subtotal of credits is £8 million, £8 million, and the subtotal of debits is £10 million. What's the total? Credits, that's positive. Debits, that's negative. What's the total? Minus £2 million. Minus £2 million. Number 10, in most English-speaking countries, how do you write minus 2,570? That would be C, minus 2,570. We use a comma here, 2,570. In some countries, some European countries, I know, instead of a comma, they use a point here. They basically reverse them, where instead of a decimal point, they would use a comma. So, for example, they would write 1,250 and 6/10. Some European countries do that. I know France does, for example. This is an English class, so we are not going to do this. In this class, this is incorrect. Okay, number 11. Which two are not another way to say about 50? About 50 means not exactly 50, but close to it. So we might say approximately. Approximately 50 means close to 50, but not exactly 50. And that's not one of the choices here, so that's another way to do it. Which two are not another way to say about 50? Around 50 is correct. 50-ish. 50-ish. We use that ish means about. Let's meet around noonish. Noon-ish. If someone says let's meet at noonish, not exactly noon, but let's meet, I don't know, 11:30, 11:50, maybe a quarter after 12, noonish. Okay, it's not a precise exact time. It's approximate. Okay, that makes sense. 50, up or down, that one doesn't work. Okay, 50, more or less, not exact, not precise, but how much did it cost? 50 more or less. 50 or thereabouts. Thereabouts means like in the neighborhood. Okay. 50 or so. 50 or so. 50 or so. Makes sense. In the region of 50. In the region. In the neighborhood of 50. Okay. On the 50. On the 50 means exactly, precisely 50. Exactly 50. If it's exactly 50, that's not about 50. Okay. So this is too precise. And 50, give or take. Give or take, give, add a little, or take, subtract a little. It's close to 50. 50, give or take. Okay? All right. So that is all of the exercises in there. And for next week, I'd like you to look at the exercises for Unit 28, which deals with phrasal verbs for banking and finance. Phrasal verb, that's a two-part word. We use them all the time. There's a lot of them. They're extremely common. For example, turn on, turn off, put away. Those are very, very common phrasal verbs. Okay, these are phrasal verbs, two-part verbs related to banking and finance. And in this one, you will see they have across and down here. This is a crossword puzzle. Okay, so you will complete the crossword puzzle with the answers from the questions here. Okay, that are all phrasal verbs. So please take a look at that one for next week, and I'll see you then.